But, as in all kinds of scientific things, people don't stop looking. And in the 1960s, 70s, a revolution swept Earth sciences. And I'd make an aside and say that the revolution was driven by our exploration of the ocean floors. Geologists put all their data they'd been gathering on the nature of the floor of the oceans together in the 1960s. That was fundamentally based on looking at the ocean floor, looking at the distribution of earthquakes around on the Earth's surface. And what they understood was, in fact, the crust of the Earth is ephemeral, and in the oceans at least, it's made along the ocean ridges and then recycled into the Earth's interior. And I'm going to draw a cartoon of that. So here's a nice ocean ridge with some ocean above it. We're making new crust, letting the mantle decompress, make new crust. That ocean crust can be taken, and I've made a very compressed view of this, to a deep sea trench. And here we have another volcano. This would be a ring of fire type volcano. This is a mid-ocean ridge. Igneous rocks, basalts are produced here, and they're also produced here. But the extra complication now is the ocean crust that you've made at the mid-ocean ridge has been exposed during its lifetime on the ocean floor, which can be the order, on average, of 100 million years, from manufacture to destruction, 100 million years, and water gets into this new crust, both at the ridges and elsewhere along the ocean floor. So suddenly we've got a complication in terms of, the oceans and atmospheres are a one-way trip through degassing of the Earth's interior, and once they're out at the Earth's surface, they never do anything else. They just do their own little cycles at the Earth's surface. But now we've got the potential for water to get into the ocean crust, and in fact the carbon dioxide that's dissolved in the ocean also makes new minerals in the ocean crust. So you have both hydrated minerals and carbonates going down into the interior of the Earth. The question becomes, of course, well, how far down do they go? Some of them get released. So now we've got water and carbon dioxide being released into this part of the Earth's mantle overlying the subducted plate. Release of those volatiles into the mantle triggers melting. You make new magma here. You've made magma here. You're now making another kind of magma here with a lot of dissolved volatiles in it. You take that magma to the Earth's surface, the gases that are dissolved in the magma, which ultimately come from the oceans, get released when you depressurize the magma. And of course those gases go up in the atmosphere and come back down again. Well, what I've described for you here is the grand cycle of volatiles on the Earth. And it's no longer a one-way trip. What comes out here can go back in. And as I said, we don't know how far down it goes. It could be that some part of this, and there are many people working on this because the problem is not solved, what fraction comes out here and what fraction goes into the Earth's interior?